just to give you a reminder to make sure we're heading in the right direction. When we're factoring something, what is the first thing we always look for? Greatest common factor. So for the first one here, is there a greatest common factor? Is there a common factor, period? Yes, there is. That common factor for the numbers is going to be 7. For the variables, remember, go ahead. X and then y squared. Good. Remember, it is the smallest power of each variable. So then we're going to take this and we're going to divide it by 7xy squared. And whatever's left over is the other factor that goes inside the parentheses. So we have the 21x to the 5th y squared divided by the 7xy squared. Bless you. What's that give us? 21 divided by 7 is 3. X to the 5th divided by x. X to the 4th. Y squared divided by y squared will cancel out. So there's nothing there. Then what's next? Okay, negative 42 divided by 7 is negative 6. What about x? X squared and just y. For the y's, it's 3 minus 2 is 1, so it's y to the 1 or just y. Then what? 35 divided by 7 is positive 5. X cancels out, and y squared. Anybody get that? Couple? Few? Good. Now on this next one, are there common factors? No. There's no number here. It's just a 1, so there's no common factor there, and there's no variable in this term. So there is no common factor. What method did we use if we didn't have any common factors? We did that reverse multiplication. Do you guys need a couple minutes to finish that one up? Okay, we'll pause there. So for number 2, remember, if we didn't have any common factors, since that's a 3-digit or 3-term polynomial, we attempted to factor it with FOIL in reverse. So we tried to turn it into two-digit numbers, or 2 binomials, we call it. The first digit of each has to multiply to make the x squared. So that's just going to be x and x. What do these last 2 digits have to multiply to make? Negative 18. We have to be careful that we do that as a negative, not a positive. Since that has to be a negative, that means one of the numbers is going to be a negative and one will be a positive. So we have 1 and 18, 2 and 9. Actually, negative 1 and 18, or a 1 and a negative 18, negative 2 and positive 9, positive 2, negative 9, negative 3 and positive 6, or negative 6 and positive 3. Which one do we want to try? Anybody get one to work out? What'd you get? Negative 2 and positive 9, okay? So let's double check that on the outside. X times 9 is 9x. On the inside, negative 2 times x is negative 2x. That adds up to 7x. Now, at first glance, that looks like that's what we want. But what we really want is, and there you go. We want a negative 7x. So that does have to be a negative 9 and a positive 2. So now this is a negative 9x and a positive 2x makes our negative 7. So that's what we want there. Does that look familiar? Okay. Do you guys need another minute to do the first equation down there yet? Okay, so I'm going to scroll those top two off the screen so you guys got room to look at these. I'm going to move this one so we got some space to work. Now I'll give you guys a minute to finish up. Let's get back here. Okay, so for number one here, where do we start? Well, we'll start on the left side, and we're going to combine everything that we can. We see parentheses. So this first set, anything to do in the parentheses? No. So we have to see if there's anything to do to the parentheses. And we see that we have to multiply by 4. 4 times 3x is 12x. And 4 times negative 7, negative 28. What's next? Negative 2 times 2x is negative 4x. And negative 2 times 1, negative 2. And then, of course, we still have the plus 2 there. And then, well, we're going to combine over here. We're going to stick on the left side for now. We could go over there and multiply, but I'm going to stay on the left side for now. 12x and negative 4x make 8x. Negative 28, negative 2, and positive 2 is negative 28. The easy way to do that one is negative 2 and positive 2 just cancel out, and you're left with the negative 28. Now we can go over to the right side. We could, like I said, we could have gone over here and multiplied it out. It's just easier for me to focus on one side and get it all done and then move over to the other side. So over here, what do we have to do? 3 times 5x is 15x. And then 3 times negative 1, negative 3. Next, negative 6 times 2x is negative 12x, and then that 1 would make a difference. You're right. Negative 12x, and then negative 6 times negative 1 is positive 6, and then okay, negative 2x plus 4. So then what? 15, negative 12, and negative 2x make 1x, or just x. And then negative 3, 6, and 4 make a positive 7. Then what? Well, we've reduced everything we can on both sides. Now it's time to start to solve. Bless you. But we see that there is an x on each side of the equation, so we have to get rid of one first. So I'm going to subtract this x, make it go away. Subtracting x over here makes that 7x minus 28 equals 7. What would we do from there? We could add 28. 7x equals 35, and then divide by 7 to get x equals 5. How many of you had x equals 5? A few of you? Okay. Let's go down to number 2. Anybody have any questions on that one that they want me to go back over? The biggest thing there is there are just a lot of steps, and of course any one step going wrong messes up the whole thing. Number 2 here looks difficult, but it's actually a lot easier than number 1 was. What's the first thing we have to do? Yeah, we see there's an x squared, but there's the same thing on both sides. So if I subtract 3x squared, it's gone here. Subtracting 3x squared from the other side also makes it go away over there. So we now have a negative 5x plus 3 equals 2x minus 11. Then what? Well, we have an x on each side. So I'm going to get rid of one of them. Which one do I want to get rid of? Smaller one, which is the, careful, negative 5 is smaller than positive 2. So to get rid of a negative 5x, we add 5x. So it's gone there. Adding 5x over here gives us 7x. So 3 is equal to 7x minus 11. And then add 11. So 14 equals 7x. And then divide by 7. So 2 equals x. Now in both of these last two, we could have taken that number we got for x and put it back in the equation and make sure it works. Make sure we get the same value on both sides. And we will. How many of you had 2 for that one? Okay. How many of you just didn't get it because you didn't have time to finish? Okay. Okay, well, that's kind of our review from last class. Yeah. Yep. Okay. So now to tie the two concepts, in our last class, the two things we talked about was we talked about factoring these algebraic numbers, which were the first two problems we did here this morning. And then we talked about solving these complex equations, which of course were these last two problems we did. So for just a second, I want to combine those two things. And I'll show you what I mean by that. Got her? Okay. So right here, x squared plus 5x plus 6 equals 0. We look at that and we think, well, there's an x squared there, and it doesn't go away. Every problem we've done so far that had an x squared in it, the x squared went away. It canceled out or disappeared somehow. Here it doesn't. But we do have this algebraic number equal to 0. There is, we talked about the zero product rule a couple of weeks ago. And the zero product rule, you don't need to know the name, you just need to know what it does. Most people are familiar with the zero product rule simply being any number times 0 equals 0. X times 0 equals 0. 7 times 0 equals 0. Negative 58 times 0 equals 0. Anything times 0 equals 0. Well, another form of that which we had mentioned looks like this. If a times b equals 0, then either a equals 0 or b equals 0, or both. For two things to multiply to be 0, at least one of the two must be 0. There are no two numbers that are not 0 that multiply to make 0. Does that make sense? I can't have like -7 times a +2 or anything like that. It's going to give me 0. One of the two numbers must be 0 if they multiply to make 0. Why does that apply to this right here? Well, because if we look at the left side here, we have one of these algebraic numbers that we were factoring. And since it equals 0, if we could factor that, we could come up with something that we might be able to solve. So if I look at this, x squared, of course, is going to be x into x. To multiply to make 6 would be +2 and +3. Is that what we want? Yeah, on the outside, x times 3 is 3x. On the inside, 2 times x is 2x. That adds up to 5x. That's what we want. We factored that. Now that we have factored that, we can look over here at this zero product rule. X plus 2 multiplied by x plus 3 equals 0. And this rule over here says if two things multiply to make 0, at least one of them has to be 0. So what this is telling us here is that either x plus 2 has to equal 0, or x plus 3 has to equal 0. Can we solve either of those equations? Yeah, we can solve both of them. Each of them can be solved. Over here, we're going to subtract 2, which would tell us that x could equal a negative 2. Over here, what would we do to solve this? Subtract 3 would give us that x equals negative 3. One or both of those is a solution to this equation. Let's double check that. So x squared plus 5x plus 6 equals 0. If I put in a negative, now remember, when we square a number, the result will always be positive. So when you put the negative number in your calculator to square it, you have to put a parentheses around it. So negative 2 squared plus 5 times negative 2 plus 6. We're testing to see if that equals 0. Negative 2 squared is a positive 4. 5 times negative 2 is a negative 10. We have our positive 6. Well, 4, negative 10, and 6 combine to make 0. So that works. The negative 2 works. Let's try the negative 3. So negative 3 squared plus 5 times negative 3 plus 6. We're testing to see if that equals 0. What's negative 3 squared? Positive 9. What's 5 times negative 3? Negative 15. Good. Positive times a negative is a negative. 5 times 3 is 15. Plus 6. Well, what is 9 plus negative 15 plus 6? 0. So both of those are solutions to that original equation. Now, not all equations are going to be quite that complex. We can run into something like this. What's simpler about this one? Well, it's already equal to 0, isn't it? And on the left side there, how would I factor that? Oops, I did something wrong here. I meant for this to be 20. I don't know where the 21 came from. I got a feeling it's going to be one of those days where I say something and think something and write it down differently. It is Thursday, you're right. So 5x squared minus 20x equals 0. On the left side here, there is a common factor of 5x. So I can factor this using just a greatest common factor. So 5x squared divided by 5x is x. 5 divided by 5 is 1. X squared divided by x is just x. So 1x or just x. How about a negative 20x divided by 5x? It's just a negative 4. And of course that still equals 0. So what's that telling us? Well, it's telling us that either 5x equals 0 or x minus 4 equals 0. How would I solve this first one here? Divided by 5, right? What's 0 divided by 5? 0. Remember, 0 can be divided. We just can't divide by 0. So x could be 0. Or, how do we solve this one? we're going to add 4, right? So x equals positive 4. So either x equals 0 or x equals a positive 4. For this class, we're not going to do a lot of equations that have x squared in them or y squared in them. But I wanted you to show that example. If any of you are going on to take tech math as your next class, you would have to be able to do this. This would be huge if you were going into like mechanical design or architectural design. Some of your structural calculations and force calculations require you to do that. Moment diagrams and stuff like that, solving for maximum or zero moments, stuff like that. If you're going into business math, you'll never see that again. At least not while you're here. If some of you do go on, I mean, many of you might be interested in going on to a 4-year degree at some point. If you go on to a 4-year degree, you will have to take a minimum of a college algebra class, and you would see that again. Okay, then. Where's our next step going? Well, what's that? Out the door? You wish. Nice thought, though. Huh. Not really.
Yeah, that's why it's very exciting.
5 times a number decreased by 2 is 38. Find the number. We went over some like this a while back. How would we go about finding that number? Okay, we replace the number with a variable. You want to use n, that works. So 5n, or 5 times n minus 2, equals 38. Perfect. We first must translate the words into an algebraic sentence or into an equation. Then what do we do with it? We solve it. We're going to add 2. Perfect. So 5n equals 40, and then n is multiplied by 5, so we get rid of it by dividing by 5. N equals 8. So the number is 8. 5 times 8 decreased by 2 would be 38. In your notes, give this one a shot. 11 more than twice the number is 49. Find the number. So what's our equation going to be? (2n plus 11). 11 more than something means 11's been added to it. So 2n plus 11 equals 49. Good. What's next? We subtract the 11. Good. Gives us 2n equals 38. Good. And then dividing by 2. N is 19. Our number is 19. Good job. The sum of two consecutive numbers is 33. Find the numbers. What does it mean to be consecutive numbers? I means one right after the other. So that would be like 10, 11, or 3, 4, or 7, 8. That's what consecutive means. So there are two numbers we have to find here. So you got to figure out some way to write it with one variable. Now this is one you could actually probably guess and check to make it work. Remember, guess and check is always a valid solution method, just picking a number and trying it and see if it works. But we want to try to write an equation here. Now on a test, if you guess and check and you get the right numbers, more power to you. I'll be fine with that. That is a valid solution method. Some problems, though, that's going to take a long time to do. So anyway, two consecutive numbers, I have to have a smaller number and a larger number. And what's the relationship going to be between those two numbers? Well, how's the larger one going to relate to the smaller one? If they're consecutive, it's one larger. So if the smaller one is x or n or whatever, the larger one is x plus 1. Two consecutive numbers. So what that means is the sum of them means you add them together. X plus 1 equals 33. Now what do? Well, we combine the x's first. So 2x plus 1 equals 33. And then we subtract the 1. 2x equals 32. And then divide by 2. X equals 16. What do you think? Okay. Are we done, by the way? Gotta be careful. The smaller number is 16. It said find the numbers. The larger one is 16 plus 1, or 17. You gotta make sure we answer the question. I want you to try this one. The sum of two consecutive even integers is 26. Find the numbers. What does it mean to be consecutive even integers? Well, that'd be like 4, 6, 12, 14, 28, 30. Even numbers. So the first one has to be even, and then the second one has to be how much larger? 2 larger. Very good. Give that one a shot in your notes. See if you can figure that one out. So I'm just going to go ahead and write this out. The sum means they're added together. So if the first one is x, the second one would be x plus 2. So then what would happen? Well, we combine the x's. X and x make 2x plus 2 equals 26. And then we're going to subtract 2, take away 2. So 2x equals 24. And then divide by 2. So x is 12. So that means the smaller one is 12. What's the other one? 14. And they do add up to 26. I want to find the two angles. This one we did about a week ago. I want to see what you remember from it. Give her a shot. But what's the relationship between those two angles? Remember, there's two things. Either they can equal each other. Do those two angles equal each other? No, you can tell by the picture that they can't be equal. Or they must add up to something. In this case, is there something obvious that they add up to? They add up to a straight line, so they're supplementary. They have to add up to 180. So we know that these two have to add up to 180. So 2x plus 1 plus 5x minus 31 have to equal 180. Now you may have also did the 5x minus 31 plus 2x plus 1. It would turn out to be the same way. So we have to combine the 2x and 5x makes 7x. What's next? One and negative 31 or negative 31 and 1 make what? Negative 30 equals 180. And then add 30. So 7x equals 210. And then divide by 7 to get x equals 30. All done? No. We have to find the angles yet. We still have to answer the question. So 5x minus 30, or 5x minus 31, I should say, becomes 5 times 30 minus 31. 5 times 30 is 150. Minus 31 is 119. 119 degrees. 2x plus 1 becomes 2 times 30 plus 1. 2 times 30 is 60, plus 1 is 61 degrees. So my two angles are 119 degrees and 61 degrees. Anybody get those? Well, let's try another one. Try that one quick. What's the relationship between these two? In this case, those two must be equal. So 5x minus 18 has to equal 3x plus 2. So when we go to solve that, our first step is, since there's an x on each side of the equal sign, our first step is to get rid of one of the x's. We'll get rid of the smaller one, the 3x. So here 5x take away 3x is 2x with the minus 18. Over here all that's left is the positive 2. Then what? Plus 18, good. So 2x equals 20. And then divide by 2, perfect. So x equals 10. So now we have to plug that back in and see what each angle is. So 3x plus 2 becomes 3 times 10 plus 2. 3 times 10 is 30, plus 2 is 32. Now we know this one has to be the same, but I'm uptight, so I'm going to double check by making sure that it comes out to be the same. So 5x becomes 5 times 10 minus 18. 5 times 10 is 50, minus 18 is 32. So they come out to be the same. The angle is 32 degrees. How do you feel about those? Not too bad? If I tell you the length of a rectangle is 4 times the width, and the perimeter is 140. Find the length and the width. See what you come up with for that one quick. So if I draw a rectangle and I label my length and my width, the relationship between them is that the length is 4 times the width. So L equals 4W, or 4 times W. Formula for perimeter, as always, is 2L plus 2W. What goes in for P? 140 equals 2 times what goes in for L? 4W, good. Plus 2 times, that's going to stay W. So the 140 here isn't going to change, but 2 times 4W is 8W, and we still have the plus 2W. And then combine 8W and 2W make 10W. Divide by the 10, good. So 14 equals W. So again, we're asked to find the width and length. So the width is 14, the length is 4 times 14, or 56. You can go back and double check that in the formula to make sure the perimeter does add up to 140. So let's step into something now that might look a little bit different. If Frank has a 24 by 40 garage, he plans to add the same amount to both the length and width. To double the perimeter. Find the new length and width. So I'm going to start out by drawing a picture here. We have the current garage, which is 24 feet by 40 feet. We're going to add the same amount to both the length and the width. So whatever that amount is, it's X. We're just going to call it X. Which means the new length is 40 plus x, or x plus 40. The new width is 24 plus x, or x plus 24. Now here's the thing. We want to double the perimeter. So how do we know what the new perimeter is going to be? Well, we have to find the old perimeter. Here's a case where you have to go back and use the old information to figure out what the new information is going to be. The old perimeter is 2 times 40 plus 2 times 24, which if you figure that out will come up to 128. What does that tell us about the new perimeter? Yeah, 128 times 2, or 256. So now we can use that to set up our equation. So the new perimeter is 256. That equals 2 times the length. So that'll be 2 times 40 plus x plus 2 times the width. What's the width going to be? 24 plus x. Good. So now we see the parentheses and we got to figure out what to do there. Nothing to do in the parentheses, but it's multiplied by 2. So 2 times 40 is 80. 2 times x is 2x. Now we move to the next set of parentheses, and again, that one is multiplied by 2. 2 times 24 is a positive 48, so plus 48. And 2 times x, positive 2x. Now what? We combine. Very good. So 256 equals, we can combine 80 and 48, make 128 plus 2x and 2x make 4x. Then what? We subtract 128. So 128 equals 4x. And then we divide by 4. 32 equals x. Is that my answer? Question is, find the length and width. So 24 plus x becomes 24 plus 32, or 56. 40 plus x becomes 40 plus 32, or 72. So the new garage is 72 by 56. The old one was 40 by 24. What do you think? I'm going to have you guys try one. Let's look at a 16 by 24 swimming pool. We'll have a deck built all around it. The perimeter on the outside of the deck will be twice the perimeter of the pool. Find the size of the deck. So what I want by the size of the deck is I want the length and the width of the deck overall. So let me illustrate this for you to show you what I mean. I'll use blue for the pool, and this pool is 16 by 24. We are going to build a deck around the pool like this. Same amount in every direction. So I want to find this length and this width. So this distance here in every direction is going to be the same, even though my picture may not show it. See if you can figure out what the length and the width of that deck are. It's not as bad as it looks. Let's see how you did here. This length here is going to be the original length of 24 plus 2 times the width of the deck. If I call that x, that would be plus 2x. The width then will be 16, the width of the pool, plus, again, 2 times the width of the deck, so 2x. The perimeter of the pool is 2 times the width of 24 plus 2 times the length of 16, which adds up to 80. So that means the perimeter of the deck has to be 160, 2 times that. So 160 equals 2 times the length, so 2 times 24 plus 2x plus 2 times the width, so 2 times 16 plus 2x. So the 160 doesn't change. 2 times 24 is 48. 2 times 2x is 4x. Now on to this set of parentheses. 2 times 16 is a positive 32. And 2 times 2x is a positive 4x. So from here, we're just going to combine. So we have the 160 stays the same. 48 and 32 make 80. 4x and 4x make 8x. We subtract 80. So 80 equals 8x. And then divide by 8. So 10 equals x. Now that's x, but we're not done yet. We have to go back and we have to tell what the new length and width is. So this is 24 plus 2 times 10. Or there's 24 plus 20 is 44. This is 16 plus 2 times 10. So 16 plus 20 is 36. So 44 by 36 is the new size of the deck. What do you think? Good stuff? I think it's about time to take our break. It is 10:12 right now, so let's come back at 10:22.